So here is a question from JEE Advanced 2023 question paper. It's from organic chemistry, particularly relating to the chapter aldehydes, ketones and carboxylic acids, the chapter. And in the following reactions, P, Q, R and S are the major products. And some statements are given about these four products and the four reactions. And if you look at the statements, what is to be understood is whether the products contain asymmetric carbon atoms. You know what is an asymmetric carbon atom? A carbon atom whose 4 valencies are satisfied by 4 different atoms or groups is known as an asymmetric carbon atom. So we have to predict the products of the reaction and have to predict whether the product contains asymmetric carbon atom. So we will take one by one. The first compound is a cyanide or a nitrile. There are 2 reactions. One reaction is the reaction with phenyl magnesium bromide, a Grignard reagent, followed by treatment with water in acid medium, followed by another reaction on the product. It's again phenyl magnesium bromide and then hydrolysis by water to get the product P. So it's a 2-step conversion. The first step, the cyanide group, it is C triple bond N. I am not going to write the entire thing. C triple bond N, I think that is enough. Okay? And this compound is CH3, CH2, CH3. CH3, here you have CH3, okay, CH2, okay, CH3, CH3, okay, CH2CN, that's the compound. So remember that this compound already has a chiral carbon here. Here is a chiral carbon. An asymmetric carbon atom is already here. CH3, CH2, CH, CH3, CH2, CN. This carbon here, that is 1, 2, 3, third from the right side, this carbon is an asymmetric carbon. It's already an asymmetric carbon. Okay? So this compound on reaction with phenyl magnesium bromide, it's an addition of a Grignard reagent to the cyanide group. Okay, it's a nucleophilic addition, you know, followed by hydrolysis. Okay, so what will be the product formed? The first step, it is CH3, CH2, CH, CH3, CH2. Okay, then C triple bond N means to the C triple bond N, phenyl magnesium bromide is added, followed by hydrolysis. And the product, you know, is a ketone, CH2. Okay, the product is a ketone. It is C double bond O C6H5. Actually, the addition of the C6H5 MgBr to the C triple bond N, the nucleophilic part of the Grignard reagent, that is C6H5 minus, is added to the carbon of the CN group, and the remaining part MgBr to nitrogen, followed by hydrolysis, and that will generate a C double bond O group. So it's a known method for the preparation of ketones, Grignard synthesis of ketones starting from cyanide. And this compound again on reaction with a second molecule of C6H5 MgBr, okay, the second molecule of C6H5 MgBr, the Grignard reagent, okay, then second step, the product formed will be CH3, CH2, okay, CH, CH3, okay, CH2, okay, C, yes, C6H5 already here, and now C6H5 here, and OMgBr, which on hydrolysis gives OH. So what you get is a tertiary alcohol. And in this carbon atom, in the tertiary alcohol, two phenyl groups are there, therefore it is not at all chiral, but the original chirality is already there. You have the asymmetric carbon atom in the substrate, so that asymmetric carbon atom is in the product 2. That means P contains an asymmetric carbon atom. So remember that P contains an asymmetric carbon atom. Now the second step of the second statement of the reaction is regarding the compound Q, where PHH means benzene, reacts with CH3COCl, acetyl chloride, in the presence of AlCl. That is a very simple reaction, that is Friedel-Crafts acylation, and the product obtained is C6H5 COCH3, the ketone, and this on reaction with phenyl magnesium bromide. Okay, the phenyl magnesium bromide is added to the carbonyl group. It's again nucleophilic addition to the carbonyl group, and you have the product C6H5, C, already CH3 is here, then C6H5, okay, hydrolysis gives OH, here you have the OH group, okay. And as far as this carbon is concerned, you have two phenyl groups on the same carbon atom, so it is no more asymmetric. So as I said, the product Q has two phenyl groups on the carbon atom, and therefore it is no more chiral. It doesn't have chiral carbon atom. Okay? So the statement that both P and Q have asymmetric carbon atom is not correct. Of course, P has an asymmetric carbon atom, but Q has no asymmetric carbon atom. So the statement A is not correct. It's a wrong statement. Now coming to the third reaction, there is the reaction of an acid chloride with dialkyl cadmium, and in the question half equivalent of the dialkyl cadmium is mentioned, which means one molecule of the ketone is formed, and the ketone has the formula CH3, CH2, CO. That is the part from the acid chloride, and the part from the dialkyl cadmium is CH2, C6H5. So this is simple synthesis of ketone starting with an acid chloride and dialkyl cadmium. Okay? So the ketone that is obtained in reaction number 3 is CH3, CH2, CO, CH2, C6H5. That's a ketone. Okay? And now this ketone on reaction with phenyl magnesium bromide, again a Grignard addition to the carbonyl group, followed by hydrolysis, you will be getting a alcohol, a tertiary alcohol, with the formula CH3, CH2, okay, C, already here CH2, C6H5, and here you have C6H5, OH. That means you are getting an alcohol which contains a asymmetric carbon atom, because one group is CH2, C6H5, the second group is CH3, CH2, the third group is C6H5, OH, and the fourth group is OH. That means this carbon atom is asymmetric. That means R is asymmetric. So P is asymmetric. P has an asymmetric carbon. Q doesn't have an asymmetric carbon, whereas R has an asymmetric carbon. So both Q and R have asymmetric carbon. That's again a wrong statement. Whereas the third statement, both P and R have asymmetric carbon atoms, is a correct statement. P has an asymmetric carbon. You have seen that. P has an asymmetric carbon. Okay. And R has an asymmetric carbon, and therefore both P and R have asymmetric carbon. Q doesn't have an asymmetric carbon. P has an asymmetric carbon. Q doesn't have an asymmetric carbon. R has an asymmetric carbon. So the statements A and B are wrong. And the third statement, both P and R have asymmetric carbon, is a correct statement. And one more point is there, that is option D there, where P has asymmetric carbon, S does not have any asymmetric carbon. Of course, P has asymmetric carbon, that is a correct statement, but we have to check whether S, the product of the reaction number 4, doesn't have any asymmetric carbon. And now what is reaction number 4? It's phenylacetaldehyde, that is a starting compound, phenylacetaldehyde. A reaction with a Grignard reagent, again addition of the Grignard reagent to the carbonyl group, and you have the product PH, CH2, okay, CH, OH, C6H5. Grignard addition to the carbonyl group, to the aldehyde group, followed by hydrolysis will give the secondary alcohol C6H5CH2, CH, C6H5OH. So that is the alcohol that is obtained, and this is now oxidized by chromium trioxide in the presence of dilute sulfuric acid. So it is oxidation by chromium trioxide, and you have the compound PH, CH2, C double bond O, C6H5. You get a ketone. The secondary alcohol and oxidation gives a ketone. So that is the second part of the reaction. Now the third part of the reaction is addition of hydrogen cyanide. It's again a nucleophilic addition to the carbonyl group, and adding hydrogen cyanide you have C6H5, CH2, okay, C, it is Cn, OH, C6H5, okay, and the reaction doesn't stop there. One more step, reaction with sulfuric acid, that means acid medium. The Cn group is hydrolyzed to COOH group to get a hydroxy acid, and this hydroxy acid on heating, of course it is sulfuric acid, heating, it's actually a process of dehydration. So there are two things happening. The Cn is converted into COOH, and OH and H being removed as a molecule of water to create a double bond. So the product of the reaction S is C6H5, CH, double bond C, the place of C, and you have the COH group, and you have C6H5. Okay? That means you are getting an unsaturated acid as a product, and it doesn't contain any asymmetric carbon atom. So the product S doesn't contain any asymmetric carbon atom. So P has asymmetric carbon atom, that is correct, and S does not have any asymmetric carbon atom, that is also correct, and therefore the statement D is correct. So the correct statements are C and D, and the wrong statements are A and B. Of course, the question is basically relating to the addition of Grignard reagent to carbonyl group, but all the reactions given have 2 or 3 steps. So you have to think very fast, then only you will be able to complete answering the question in the stipulated time. Okay?